What is Backstage? Backstage is an open source framework for building developer portals powered by a centralized software catalog. Backstage restores order to your microservices and infrastructure and enables your product teams to ship high quality code quickly without compromising autonomy. Backstage unifies all your infrastructure tooling, services, and documentation to create a streamlined development environment from end to end. Out of the box, Backstage includes Backstage Software Catalog for managing all your software, that is, microservices, libraries, data pipelines, websites, ML models, and so on. And Backstage Software Templates for quickly spinning up new projects and standardizing your tooling with your organization's best practices. Backstage Tech Docs for making it easy to create, maintain, find, and use technical documentation using a docs-like code approach. Plus a growing ecosystem of open source plugins that further expand Backstage's customizability and functionality. Backstage and the CNCF. Backstage is a CNCF incubation project after graduating from Sandbox. Read the announcement in the Cloud Native Computing Foundation website. So the benefits of Backstage are, for example, for engineering managers, it allows you to maintain standards and best practices across the organization, and it can help you manage your whole tech ecosystem from migrations to test certification. For end users or developers, it makes it fast and simple to build software components in a standardized way, and it provides a central place to manage all projects and documentation. For platform engineers, it enables extensibility and scalability by letting you easily integrate new tools and services via plugins, as well as extending the functionality of existing ones. For everyone, it is a single consistent experience that ties all your infrastructure tooling, resources, standards, owners, contributors, and administrators together in one place. If you have questions on or want support, please join our Discord channel. The architecture overview of the Backstage is the terminology. First, let's look into the terminology. Backstage is organized into three main components, each catering to different groups of contributors who interact with Backstage in distinct ways. So core contributors, this includes the base functionality developed by core developers within the open source project. App component, the app represents a deployed instance of Backstage application, customized and maintained by app developers, typically a productivity team within an organization. It integrates core functionalities with additional plugins. And we have plugins. These provide additional functionalities to enhance the usefulness of your Backstage application. Plugins can be company specific or open sourced, and it is reusable. At Spotify, they have over 100 plugins created by more than 50 different teams, significantly enriching the unified developer experience by incorporating contributions from various infrastructure teams. So first of all, coming to the overview of the Backstage infrastructure or architecture, the following diagram shows how Backstage might look when deployed inside a company which uses the Tech Radar plugin, the Lighthouse plugin, the Circle CI plugin, and the software catalog. There are three main components in this architecture. The first one is the core Backstage UI, and the second, the UI plugins and their backing services. And then the third part is the database. Running this architecture in a real environment typically involves containerizing the components. Various commands are provided for accomplishing this. So basically, the user interface, the UI is a thin client-side wrapper around a set of plugins. It provides some core UI components and libraries for shared activities, such as config management. Each plugin typically makes itself available in the UI on a dedicated URL. For example, the Lighthouse plugin is registered with the UI on slash Lighthouse. The Circle CI plugin is available on slash Circle CI. Plugins and plugin backends. So each plugin is a client-side application which mounts itself on the UI. Plugins are written in TypeScript or JavaScript. They each live in their own directory in the plugins folder. For example, the source code for the catalog plugin is available at plugins/catalog. Each plugin is a client-side application which mounts itself on the UI. So installing a plugin, how do we install a plugin? Plugins are typically installed as React components in your Backstage application. For example, here is a file that imports many full page plugins in the Backstage sample app. Let's open app.tsx. An example of one of these plugin components in the is the catalog index page, which is a full page view that allows you to browse entities in the Backstage catalog. It is installed in the app by importing it and adding it as an element like this. So we can import catalog next page from Backstage plugin catalog, and there will be some lines here. And usually we'll declare routes like this. And we have flat routes. And there'll be some routes here. And then we'll include something like this, path as catalog. Element is going to be catalog index page. Note that we use slash catalog as our path to this plugin page, but we can choose any route we want to this page as long as it doesn't collide with the routes that we choose for other plugins in the app. So these components that are exported from plugins are referred to as plugin extension components or extension components simply. They are regular React components, but in addition to being able to be rendered by React, they also contain various pieces of metadata that is used to wire together the entire application. Extension components are created using create extension methods, which you can read more about in the composability documentation of the Backstage website. As of this moment, there is no config-based install procedure for plugins. Some code changes are required for installing a plugin. The plugin architecture includes architecturally, plugins can take three forms. Number one is standalone plugins. Number two, service-backed plugins, and number three, third-party backed plugins. So standard plugins, standalone plugins run entirely in the browser. The TechRadar plugin, for example, simply renders hard-coded information. It doesn't make any API requests to other services. The architecture of the TechRadar installed into the Backstage app can be seen in the documentation. Service-backed plugins. So service-backed plugins make API requests to a service which is within the purview of the organization running the Backstage instance. The Lighthouse plugin, for example, makes requests to the Lighthouse audit service. The Lighthouse audit service is a microservice which runs a copy of Google's Lighthouse library and stores the result in the Postgres database. The architecture, again, can be referred in the documentation. The software catalog in Backstage is another example of a service-backed plugin. So it requires a list of services or entities from the Backstage backend service and renders them in a table for the user. That's about. And the next thing is third-party backed plugins. The third-party backed plugins are similar to service-backed plugins. The main difference is that the service which backs the plugin is hosted outside of the ecosystem of the company hosting the Backstage instance. The Circle CI plugin is an example of a third-party backed plugin. Circle CI is a SaaS service which can be used without any knowledge of Backstage. It has an API which a Backstage plugin consumes to display content. Requests going to Circle CI from the user's browser are passed through a proxy service that Backstage provides. Without this, the requests would be blocked by cross-origin request resource sharing policies, which prevents a browser page served at example.com from serving resources hosted at circleci.com. So it's a standard networking thing. So let's come to the package architecture. So Backstage relies heavily on NPM packages, both for distribution of libraries and structuring of code within projects. While the way you structure your Backstage project is up to you, there is a set of established patterns that we encourage you to follow. These patterns can help set up a sound project structure as well as provide familiarity between different Backstage projects. So it takes the point of view of an individual plugin and all of the packages that it may contain, indicated by the thicker borders in the diagram in the documentation. Note that not all libraries package lists are complete, as packages have been omitted for brevity. So coming to the overview of the package architecture, the arrows in the diagram above in the documentation indicates a runtime dependency on the code of the target package. This strict dependency graph only applies to runtime dependencies. And there may be dev dependencies that break the rules of this table for the purpose of testing. So while there are some arrows that show a dependency on a collection of front-end, back-end, and isomorphic packages, those still have to abide by important compatibility rules shown in the bottom left. The app and backend packages are the entry points of a Backstage project. The app package is the front-end application that brings together a collection of front-end plugins and customizes them to fit an organization. While the backend package is the backend service that powers the Backstage application. Worth noting is that there can be more than one instance of each of these packages within a project. Particularly, the backend packages can benefit from being split up into smaller deployment units that each serve their own purpose with a smaller collection of plugins. And coming to the plugin packages, a typical plugin consists of up to 5 packages, 2 front-end ones, 2 backend, and 1 isomorphic package. All packages within the plugin must share a common prefix, typically of the form scope slash plugin plugin, and then the plugin ID. But alternatives like backstage plugin ID or scope slash plugin scope slash backstage plugin ID are also valid. Along with this prefix, each of the packages have their own unique suffix that denotes their role. In addition to these 5 plugin packages, it's also possible for a plugin to have additional front-end and back-end modules that can be installed to enable optional features. For a full list of suffixes and their roles, see the plugin package structure ADR. The -react, -common, and -node plugin packages together form the external library of a plugin. The plugin library enables other plugins to build on top of and extend a plugin, and likewise allows the plugin to depend on and extend other plugins. Because of this, it is preferable that plugin library packages allow duplicate installations of themselves, as you may end up with a mix of versions being installed as dependencies of various plugins. It is also forbidden for plugins to directly import non-library packages from other plugins. All communication between plugins must be handled through libraries and the application itself. So the front-end packages. The front-end packages are grouped into 2 main groups. The first one is front-end app core, which is the set of packages that are only used by the app package itself. These packages help build up the core structure of the app, as well as provide a foundation for the plugin libraries to rely upon. The second group is the rest of the shared packages, further divided into front-end plugin core and front-end libraries. The core packages are considered particularly stable and form the core of the front-end framework. Their most important role is to form the boundary around each plugin and provide a set of tools that helps you combine a collection of plugins into a running application. The rest of the front-end packages are more traditional libraries that serve as building blocks to create plugins. So coming to backend packages, the backend library packages do not currently share a similar plugin architecture as the front-end packages. They are instead simply a collection of building blocks and patterns that help you build backend services. This is, however, likely to change in the future. And the common packages. Let's discuss about the common packages. The common packages are the packages effectively depended on by all the other packages or all other pages. This is a much smaller set of packages, but they are also very pervasive because the common packages are isomorphic and must execute both in the front end and back end. They are never allowed to depend on any of the front end or back end packages. The Backstage CLI is in a category of its own and is depended on by virtually all other packages. It's not a library in itself, though. and must always be a development dependency only. Deciding where you place your code is explained like this. It can sometimes be difficult to decide where to place your plugin code. For example, should it go directly in the hyphen backend plugin package or the hyphen node package? As a general guideline, you should try to keep the exposure of your code as low as possible. If it doesn't need to be public API, it's best to avoid it. If you don't need it to be used by other plugins, then keep it directly in the plugin packages. So you can refer to a chart that explains how to decide on where to put your code in the documentation page. Coming to the databases, as we have seen, both the Lighthouse audit service and catalog backend requires a database to work with. The Backstage backend and its built-in plugins are based on the Next library and set up a separate logical database per plugin. This gives great isolation and lets them perform migrations and evolve separately from each other. The Next library supports a multitude of databases, but Backstage at this time of writing is um, tested primarily against two of them, which is SQLite, which is mainly used as a in-memory or mock or test database, and Postgres, which is the preferred production database. Other databases such as the MySQL variants are reported to work, but aren't fully tested yet. So coming to the cache architecture, the Backstage backend and its built-in plugins are also able to leverage cache stores as a means of improving performance or reliability. Similar to how databases are supported, plugins receive logically separated cache connections, which are powered by Kiwi under the hood. At this time Backstage can be configured to use one of three cache stores: memory, which is mainly used for local testing; memcache or Redis, which are cache stores better suited for production deployments. The right cache store for your Backstage instance will depend on your own runtime constraints and those required of plugins you are running. Using memory for cache will look something like this. So inside the app config, you can write backend looks like this: cache store memory. Using memcache will look like this: memcache, and then connection. It will be user password at cache your memcache address. And using Redis will look like this: Redis user as like this. Contributions supporting other cache stores are also welcome from the documentation. So, containerization. So the example Backstage architecture shown in the documentation would dockerize into three separate Docker images. That is, one is front-end container, second back-end container, and third one the Lighthouse audit service container. The Backstage container can be built by running the following commands. The commands are yarn run. Sorry. So yarn run build and yarn run build image. This will create a container called example backend. And the Lighthouse audit service container is already publicly available in Docker Hub and can be downloaded and run with Docker run, Spotify, slash lighthouse audit service latest. Okay. A little bit of background about why Backstage came into existence. The Spotify story, actually. The Backstage was born out of necessity at Spotify. So they have found that as they grew, their infrastructure was becoming more fragmented and their engineers were less productive. Instead of building and testing code, teams were spending more time looking for the right information just to get started. Whereas the API for the service we are all supposed to be using, what version of that framework is everyone on? The service isn't responding. Who owns it? It can't find documentation. It can't find documentation for anything. Just these kind of questions arose. Context switching and cognitive overload were dragging engineers down by day. So they needed to make it easier for their engineers to do their work without having to become an expert in every aspect of infrastructure tooling. So their idea was to centralize and simplify end-to-end software development with an abstraction layer that sits on top of all of their infrastructure and developer tooling. That's what is Backstage. It's a developer portal powered by centralized software catalog with a plugin architecture that makes it endlessly extensible and customizable. So manage all your services, software, tooling, and testing in Backstage. Start building a new microservice using an automated template in Backstage. Create, maintain, and find the documentation for all the software in Backstage. One place for everything, accessible to everyone. Backstage was originally built by Spotify and then donated to the CNCF. Backstage is currently in the incubation phase of the CNCF. Actually, their vision is their goal is to provide engineers with the best developer experience in the world. A fantastic developer experience leads to happy, creative, and productive engineers. So their belief is that engineers should not have to be experts in various infrastructure tools to be productive. So infrastructure should be abstracted away so that we can return to building and scaling quickly and safely. So they are working on making Backstage the trusted standard toolbox for the open source infrastructure landscape. This think of it like Kubernetes for developer experience. They realize this is a ambitious goal and they can't do it alone. So if this sounds interesting or you'd like to help them shape their product, they'd love to talk about it. So I'll tell a little bit about their roadmap, the Backstage roadmap. So Backstage is still under rapid development, and um, this section details in the project's public roadmap. This this is not a complete list of all work happening in and around the Backstage project. It only highlights the highest priority initiatives worked on by the core maintainers. So 2025 Spring Roadmap, the initiatives listed in this section are planned for release within the next half year, starting in November 2024. The roadmap is updated every 6 months, and the next update is planned for April 2024. So new front-end system ready for adoption. The new front-end system still needs more work, and the next milestone is to improve it to the point where there is enough confidence in the design to start encouraging adoption in the community. So we can follow along with this work in the meta issue. This milestone also includes reaching and executing rollout phase 2. So once the initial milestone is reached, the goal is to also build out broader support for the new front-end system in the core plugins. So rework pull requests and issue processes. Our their current review and issue triage process is centered around either core or project area maintainers. The goal of this initiative is to make it simpler for more members of the community to be involved and contribute to this process. So catalog performance is another aspect. The goal of this initiative is to improve the performance of the software catalog, both in terms of speeding up the read API and improving the ingestion process. So how to influence the roadmap? How can you influence the roadmap? So as we evolve Backstage, we want you to contribute actively in the journey to define the most effective developer experience in the world. So a roadmap is only useful if it captures real needs. If you have success stories, feedback, or ideas, we want to hear from you. If you plan to work for or are already working on a new or existing feature, please let us know so that we can update the roadmap accordingly. So we are also happy to share knowledge and context that will help you feature land successfully. You can also head over to the contributing guidelines to get started. If you have specific questions about the roadmap, please contact an issue, create an issue, plug in, ping on Discord, or book time with the Spotify team. So the Backstage threat model. The threat model outlines key security considerations of Backstage for operations, operators, developers, and security researchers. This is a living document which and will evolve and be expanded alongside the Backstage project as relevant. See security policy and advisories in the Backstage GitHub repository for details on reporting security vulnerabilities and advisories on fixed security flaws. So the trust model is the Backstage trust model is divided into three groups with different trust levels. An internal user is an authenticated user that generally belongs to the organization of a particular Backstage deployment. These users are trusted to the extent that they're not expected to compromise the availability of Backstage, but they are not trusted to not compromise data confidentiality or integrity. The next role is the operator. An operator is a user responsible for configuring and maintaining an instance of Backstage. Operators are fully trusted since they operate the system and database and therefore have root access to the host system. Additional measures can be taken by adopters of Backstage in order to restrict or observe the access of this group, but that falls outside of the current scope of Backstage. A builder is another role. A builder is an internal or external code contributor and end up having a similar level of access as operators. When installing Backstage plugins, you should vet them just like any other package for an external source. While it's possible to limit the impact of, for example, a supply chain attack by splitting the deployment into separate services with different plugins, the Backstage project itself does not aim to prevent these kinds of attacks or in any other way sandbox or limit the access of these plugins. So an external user is another role. An external user is a user that does not belong to the other two groups. For example, malicious actor outside of the organization. The security model of Backstage currently assumes that this group does not have any direct access to Backstage. And it is the responsibility of each adopter of Backstage to make sure this is the case. So coming to the responsibilities of the operator. So Backstage is primarily designed to be deployed in a protected environment rather than being exposed to the public internet. From a confidentiality and integrity perspective, Backstage is designed to protect against unauthorized access to data and to ensure that data is not tampered with. However, Backstage does not provide more than rudimentary protection against denial of service attacks, and it is the responsibility of the operator to ensure that the Backstage deployment is protected against such attacks. A common and recommended way to protect a Backstage deployment from unauthorized access is to deploy it behind an authenticating proxy, such as AWS ALB or GCP's IAP or Cloudflare Access. Users that are signed into Backstage generally have full access to all information and actions. If more fine-grained control is required, the permission system should be enabled and configured to restrict access as necessary. So an operator is responsible for protecting the integrity of configuration files, as it may otherwise be possible to introduce vulnerable configurations, as well as the confidentiality of configured secrets related to Backstage, as these typically include authentication details to third-party systems. The operator is ultimately responsible for auditing usage of internal and external plugins, as these run on the host system and have access to configuration and secrets. When installing plugins from sources like npm, you should vet these in the same way that you would vet any other package installed from that source. The operator is also responsible for maintaining the resolved npm dependencies of their Backstage project. This involves ensuring that yarn lock receives updated versions of packages that have vulnerabilities when those fixed versions are in range of what the Backstage plugins request in their respective package.json files. This is commonly done by employing automated tooling such as Dependabot, Snake, and Renovate on your own repository. So when fixed versions exist that are not in range of what Backstage packages request, or when larger operations such as switching out an entire dependency for another one is required, maintainers collaborate with contributors to try to address these dependency declarations in the main project as soon as possible. The built-in protection against unauthorized access does not by default include protection of the front-end bundle. The front-end bundle includes all the code of your front-end plugins and code in minified form, as well as any other front-end resources like images, fonts, etc. If this is a concern, you can use the experimental public entry point to create two separate front-end builds where authenticated users only have access to the full one. So common backend configuration. There are many common facilities that are configured centrally and available to all Backstage backend plugins. For example, there is a database service that provides access to a SQL database, scheduler service for scheduling long-running tasks, logger service as a general logging facility, and URL reader service for reading content from external sources. These are all configured either directly in code or within the backend block of the static configuration. The appropriate care needs to be taken to ensure that any secrets remain confidential and no malicious configuration is injected. In a typical Backstage setup, there is no boundary between plugins that run on the same host. Likewise, there is no boundary between plugins that share the same database access. Any plugin that is running on a host that has access to the logical database of any other plugin should be considered to have full access to that other plugin. For example, even if you deploy the auth and catalog plugins on separate hosts with separate configuration and credentials, the catalog plugin is still considered to have full access to the auth plugin as long as the catalog plugin has access to the auth plugin's logical database. The only way to create a boundary between the two plugins is to deploy them in such a way that they do not have access to each other's database. This applies to the database facility as well as any other shared resources, such as the cache. The URL reader service facility is of particular interest for a secure Backstage configuration. In particular, the backend.reading.allow configuration lists the hosts that you trust the backend to be able to read content from on behalf of the user. It is extremely important that this list does not, for example, allow access to instance metadata endpoints of cloud providers or other endpoints that your Backstage instance may have access to, which contain sensitive information and so on. In general, it is recommended to keep the list minimal and only allow reading from required endpoints. The same concerns apply to custom implementations of the URL reader interface if you need to implement these through the code. Note that the URL reader service system operates with a service context and is not integrated with the Backstage permission system or other external access control mechanisms. This means users of your Backstage instance may be able to read external content which that individual should not have access to. For example, the $text placeholder in a catalog info YAML can be used to read contents from a source such as GitHub repository that the user does not have direct access to. If this is a concern, it is recommended to either disable or replace the resolvers in the catalog placeholder processor and similar features in any other plugin. And coming to the authentication, Backstage provides authentication of users through the auth plugin, which primarily acts as an authorization server for different OAuth 2.0 providers in provider integrations. So these integrations can both serve the purpose of signing users into Backstage as well as providing delegated access to external resources and are also subject to the common concerns of implementing secure OAuth 2.0 authorization service. All auth provider integrations are disabled by default and need to be enabled through configuration in order to be used. For each Backstage installation, it is recommended to only enable the minimal set of providers that are in use by the interface, used by the instance. In order to use an auth provider to sign in users into Backstage, it needs to be configured with a sign-in resolver. The sign-in resolver is a sensitive part of configuring Backstage, and it's important that it always resolves user identities correctly and rejects unauthorized users. There are a number of built-in sign-in resolvers that can simplify configuration, or you can implement your own custom sign-in resolver in code. Either way, it is very important that these resolvers map user identities correctly. You should always use minimum number of sign-in resolvers necessary to avoid risk of account hijacking. So Backstage also supports authentication through an authenticating reverse proxy such as AWS ALB, where the user identity is read from the incoming proxy's decorated request. The following proxy auth providers verify the signature of incoming requests and are therefore safe to deploy with direct access by users: AWS ALB, CF Access, and GCP IAP. Providers like OAuth2 proxy do not verify the incoming request and can therefore be spoofed by a malicious internal user to supply the auth backend with forged identity information. It's therefore highly recommended to restrict access to the OAuth2 proxy endpoints or use a different provider. As part of signing in with a sign-in resolver, a Backstage token is issued containing the resolved user identity. The tokens are asymmetrically signed JSON Web Tokens with the public keys available to any service that wishes to verify a token. The signing keys are rotated continuously and are unique to each installation of Backstage, meaning that Backstage tokens are not shared across installations. The token contains claims for the user identity and ownership information, which can be used to determine what Backstage resources are owned by that user or group. It is important that this token cannot be forced outside of the auth plugin, with the exception of other plugins deployed in the same backend service or sharing the same database. For a for a high security deployment, the auth backend should therefore be deployed in a separate service with its own database. The token is used to provide the identity of the user within the Backstage system and is used throughout Backstage plugins to control access. It is important that the ownership resolution logic is consistent across the entire Backstage ecosystem with no possibility of misinterpreting the ownership information. One of the claims in a user token is that one of the claims in a user token is the user identity proof or UIP. So this is an additional signature of the token that allows for offline token information or token transformation. By replacing the original signature with the UIP, the token is still proof of a user identity, but it is no longer acts as a full access token and will be rejected by most plugin endpoints. Plugins can explicitly allow use of this limited token where required, but this should only be used when necessary when a full token is not available, and ideally just for read-only access. Use cases for limited users token includes cookie authentication of static assets, storage of user identity proofs in a database, and so on. The communication across backend plugins uses a similar authentication scheme to the user authentication. Each backend plugin generates and publishes its own set of keys that it uses to sign its tokens. And the public keys are shared with all other plugins for verification. The expected location of each plugin's published JWKs is determined by the discovery service implementation in the backend, which means that it is vital for any custom implementation of that service to be careful with user input. The token signed by each plugin contains both the source and target plugin ID, which means that the token cannot be reused to access other plugins. When forwarding a user identity in a call across backend plugins, only the limited user token with UIP is used, wrapped in a new service token that is signed by the calling plugin. This means that the receiving plugin can trust the user identity, but it is not able to make the further calls on behalf of the user except for with the plugins that it is authorized to call. So that is except for any endpoints in other plugins that accept limited user tokens, which is a reason to avoid accepting them when possible. And catalog. Operators should configure catalog rules to limit the allowed entity kinds that users can define. In general, it is best to restrict definition of user, group, and template entities so that internal users cannot register additional ones. Template entities define actions that are executed on the backend hosts. And while the goal is for these actions to be secure, regardless of input, it is still a more sensitive context and it is recommended that you protect it with additional checks. It is very important to not allow registration of user and group entities if you ingest and rely on these as organizational data in your catalog. Doing so could otherwise open up for the ability to impersonate users and confuse group membership information. You should always ingest organization data using a statically configured catalog location or an entity provider reading from a trusted source. The entities emitted directly by an entity provider are always trusted and rules are not applied to them. But any entities produced further down the chain are still subject to the rules. The catalog does not aim to protect against resource exhaustion attacks in its default setup. If you need to prevent your internal users from being able to register large amounts of entities, then it is recommended to disable entity registration and use a different approach for discovering entities. One way to mitigate any resource exhaustion attacks is to only allow the catalog to read from trusted SCM sources that have an audit trail. Catalog currently lacks limits for entity hierarchy depths and entity size, which we hope to address in the future. By default, all internal users are allowed to create and delete entities. If this does not fit your organization's needs, it is recommended to enable and configure the permission system to restrict these operations. Scaffolded. So by default, scaffolding jobs execute directly on the host machine, including any actions defined in the template. Because the scaffolder templates are considered a more sensitive area, it is recommended to control access to create and update templates to trusted parties. Template execution is intended to be secure regardless of input, but we still recommend this additional layer of protection. The string templating is executed in a Node VM sandbox to mitigate the possibility of remote code execution attacks. The scaffolder often has elevated permissions to, for example, create repositories in a GitHub organization. The operator should therefore be cautious of scaffolder templates that, for example, delete or update existing resources, as the user input is typically user defined and can therefore delete or modify resources maliciously or by mistake. So one strategy that allows you to reduce the access that the scaffolder service has is to rely on user credentials when executing actions. For example, a GitHub app integration could be configured with read-only permissions with a separate user OAuth token used to create repositories. This requires that your users have access to create repositories in the first place. The operator should audit install scaffolding actions just like any other plugin package. It is also important to verify that installed actions fall in line with your own security requirements, as some actions might be intended for more relaxed environments. By default, all internal users are allowed to execute templates in the scaffolder. If this does not fit your organization's needs, it is recommended to enable and configure the permission system to restrict these operations. Tech docs. Tech docs backend can be broadly configured into two ways. The default is when tech docs builder is set to local, in which documentation is generated on demand and stored locally by the tech docs backend. When tech docs builder is set to external instead, documentation is assumed to be generated by an external process, example in a CI/CD pipeline, and merely read from a configured external storage provider. When documentation is generated locally, integrators are responsible for ensuring secure configuration of file system permissions in the location where generated assets are stored. So when documentation is generated externally, integrators are responsible for access control and permissions between the external process that generates the documentation, the storage provider where documentation assets are published, and the tech docs backend. Regardless of backend configuration, the TechDocs frontend does not trust the generated HTML of any documentation sites and therefore applies a strict serialization process before rendering out any content to users. By default, all TechDocs documentation is visible to all Backstage users. Access can be restricted to TechDocs sites by configuring view permissions for the catalog. Last one is the proxy. So the proxy backend acts as utility for front-end plugins to access remote services that may not be set up to receive traffic directly from the Backstage frontend. Typical reasons for this would be that the upstream service does not provide the appropriate CORS headers or does not serve its content over HTTPS. The proxy entries are configured through static configuration Each entry has a mount path and an upstream target, and also supports other options such as limiting the allowed methods or injecting additional headers. It is recommended to avoid injecting authentication headers for upstream services, as this is a risky way to decorate requests with credentials. Anyone with access to your Backstage deployment will be able to make requests to the upstream service using the injected credentials. It is recommended that you instead create a backend plugin that forwards individual requests to the upstream service in a secure way. In case you do end up injecting credentials into upstream requests, be sure that you are not exposing any sensitive information or actions. You should also restrict the access as much as possible, for example, using the allow methods option to limit the methods that can be used, and using tokens with the minimum required authorization scope. Release and versioning policy. So the Backstage project is comprised of a set of software components that together form the Backstage platform. So these components are both plugins as well as core platform libraries and tools. Each component is distributed as a collection of packages, which in the end is what you end up consuming as an adopter of Backstage. The number of Backstage packages that build up an application can be quite large. So in the order of hundreds, with just core platform packages being counted to dozens. This creates a challenge for the integrators of a Backstage project, as there are a lot of moving parts and pieces to keep up to date. So our solution to this is collecting our most used components and their packages into an umbrella version that we call a Backstage release. Each release is a collection of packages or specific versions that have been verified to work together. Think of it as a toolbox that comes with batteries included, but you can always add more plugins and libraries from the open source ecosystem as well as build your own. So the release lines. The Backstage project is structured around two different release lines, a primary main release line and a next release line that serves as a preview and pre-release of the next mainline release. Each of these release lines have their own release cadence and versioning policy. The main release line. So release cadence is monthly, specifically on the Tuesday before the third Wednesday of each month. The first release took place in March 2022. The main release line is versioned with a major, minor, and patch version, but does not adhere to somewhere semantic versioning. The version format is major.minor.patch, for example, 1.3.0. So an increment of the major version denotes a significant improvement or change to the Backstage platform. It may come with a large new set of features or a switch in the product direction. So these will be few and far between and do not have any set cadence. Policy-wise, they are no different than a minor release. So each regularly scheduled release will bring an increment to the minor version as long as it is not a major release. Each new minor version can contain new functionality, breaking changes, and bug fixes according to the versioning policy. So patch versions will only be released to address critical bug fixes. They're not bound to the regular cadence and are instead released whenever needed. So next release line. The release cadence is weekly, specifically on Tuesdays. The next release line is a weekly release of the project. Consuming these releases gives you early access to upcoming functionality in Backstage. There are, however, fewer guarantees around breaking changes in these releases, where moving from one release to the next may introduce significant breaking changes. Release versioning policy. The versioning policies applies to the mainline release are as follows. So breaking changes in packages that have reached version greater than or equal to 1.0.0 will only be done when necessary and with the goal of having minimal impact. When possible, there will always be a deprecation path for a breaking change. Security fixes may be backported to older releases based on the simplicity of the upgrade path and the severity of the vulnerability. Vulnerabilities with a severity of high or critical will always be backported to releases for the last 6 months if feasible, but reports are valid only if reproducible in the most recent release, and bug fixes are only applied to the next release. Bug reports are valid only if reproducible in the most recent release, and bug fixes are only applied to the next release. We will do our best to adhere to this policy. SKU policy. In order for Backstage to function properly, the following versioning rules must be followed. The rules are referring to the package package architecture. The version of all packages for each of the app core groups must be from the same Backstage release. For example, for each front-end and back-end setup, the app core packages must be ahead of or on the same Backstage release as the plugin core packages, including transitive dependencies of all installed plugins and modules. For any given plugin, the version of all packages from the plugin core and library groups must be from the same Backstage release. Front-end plugins with a corresponding backend plugin should be from the same release. The update to the backend plugin must be deployed before or together with the update to the front-end plugin. It is allowed and often expected that the plugin core and library packages are from older releases than the app core package. It is also allowed to have duplicate installations of the plugin core and library packages. This is all to make sure that upgrading Backstage is as smooth as possible and allows for more flexibility across the entire plugin ecosystem. Package versioning policy. Every individual package is versioned according to semantic versioning. This versioning is completely decoupled with the Backstage release versioning, meaning you might, for example, have Backstage slash core plugin API version 3.1.4 be part of the 1.12 Backstage release. The following versioning policy applies to all packages. Breaking changes are noted in the changelog and documentation is updated. Breaking changes are prefixed with breaking keyword in the changelog. All public exports are considered stable and will have an entry in the changelog. Breaking changes are recommended to document a clear upgrade path in the changelog. This may be omitted for newly introduced or unstable packages. For packages at version 1.0.0 or above, the following policies also applies. All exports are marked with a release stage. Breaking changes to stable exports include a deprecation phase if possible. The deprecation must have been released for at least one mainline release before it can be removed. The release of breaking changes document a clear upgrade path in the changelog, both when deprecations are introduced and when they are removed. Breaking changes to alpha or beta exports must result in at least a minor version bump and may be done without a deprecation period. Changes that are not considered breaking. So there are a few changes that would typically be considered breaking changes, but that we make exceptions for. This is both to be able to evolve the project more rapidly, also because the alternative ends up having a bigger impact on users. For all utility APIs and backend services that have a built-in implementation, we only consider the API stability for consumers of those interfaces. This means that it is not considered a breaking change to break the contract for producers of the interface. Changes that fall under the above rule must be marked with breaking producers in the changelog. For any case of dependency injection, it is not considered a breaking change to add a dependency on a utility API or backend service that is provided by the framework. So this includes any dependency that is provided by the backstage slash app defaults and backstage slash backend defaults packages. Release stages. The release stages, alpha, beta, public, refer to the TSDoc documentation tag of the export and are also visible in the API report of each package. Backstage uses three stages to indicate the stability for each individual package export. Public is considered stable and are available in the main package entry point. Beta not visible in the main package entry point. Beta exports must be accessed via package name slash beta or package name slash alpha imports. Alpha here is the dragons. Not visible in the main package entry point. Alpha exports must be accessed via package name slash alpha imports. Node.js releases. So the Backstage project uses Node.js for both its development tooling and backend runtime. In order for expectations to be clear, we use the following schedule for determining the Node.js releases that we support. At any given point in time, we support exactly two adjacent even number releases of Node.js, for example, version 12 and version 14. Once a new Node.js release becomes active, long-term support, we switch to support that release and the previous one. The switch is not immediate, but done as soon as possible. You can find the Node.js version supported by each release in the engines field in the root package JSON of a new app. So when we say supporting a Node.js release, that means the following. The CI pipeline in the main Backstage repo tests towards the supported releases, and we encourage any other Backstage related projects to do the same. New Backstage projects created with Backstage Create app will have their engines.node version set accordingly. Dropping compatibility with unsupported releases is not considered a breaking change. This includes using new syntax or APIs, as well as bumping dependencies that drop support for these versions. Based on the above Backstage support, Node.js 20 and 22 as of the 1.33.0 release. TypeScript releases. The Backstage project uses TypeScript for type checking within the project as well as external APIs and documentation. So it is important to have a clear policy for which TypeScript versions we support, since we want to be able to adopt new TypeScript features, but at the same time not break existing projects that are using older versions. The TypeScript release cadence is roughly even every 3 months. So an important aspect of TypeScript versioning is that it does not follow semantic versions. In particular, there is no differentiation between major and minor versions. Both of them are breaking. One way to think about it is to merge the two. For example, version 4.7 can be considered major version 47, 5.0 is 50, and so on. Within these releases, there can be a number of patch releases which do follow somewhere. Our policy is to support the last three TypeScript versions, for example, 48, 49, and 50. Converted to time, this means that we typically support the TypeScript version from the last 6 to 9 months, depending on where in the TypeScript release window we are. This policy applies as a snapshot at the time of any given Backstage release. New TypeScript releases only apply to the following Backstage mainline release, not to the current one. For anyone maintaining their own Backstage project, this means that you should strive to pump up to the latest TypeScript version at least every 6 months, or you may encounter breaking changes as you upgrade Backstage packages. If you encounter any issues in doing so, please file an issue in the main Backstage repository. As per the policy, we should always support the latest version in order to ensure that we do not start using new TypeScript features too early. The Backstage project itself uses the version at the beginning of the currently supported window. So in the above example, that would be version 4.8. So PostgreSQL releases. The Backstage project recommends and supports using PostgreSQL for persistent storage. The PostgreSQL versioning policy is to release a new major version every year with new features, which is then supported for 5 years after its initial release. So our policy mirrors the Postgres versioning policy. We will support the last five major versions. We will also test the newest and oldest versions in that range. For example, if the range we support is currently 13 to 17, then we would only test 13 and 17 explicitly.